In a previous video, we studied what is factors, say, that we need to consider when we are predicting products, and we have, say, two competing reactions, SN2E2 or SN1E1. And we talk about the structure of the substrate, and here we were talking about alkyl halides and knowing how to classify those as primary, secondary, tertiary. We also talk about, say, the nature of the leaving group, and we talk about nucleophiles being, say, neutral or charged species. Now, another factor that is important here to consider is the solvents. And here we're going to have, say, two main types. We have polar protic solvents, and we're going to recognize those because they have hydrogens attached to an atom that is very electronegative. Here, examples are oxygen and nitrogen. Examples of polar protic solvents are, say, water, and I'm drawing that explicitly with the hydrogens to show that hydrogens are attached to oxygen. And notice that this is also capable of hydrogen bonding with molecules of the same kind. Similarly, if you had ethanol, in ethanol you have a hydrogen attached to oxygen, again capable of hydrogen bond. So it is polar protic, you have a hydrogen attached to an electronegative atom. Another type of example, they say that you have acetic acid. Acetic acid has a hydrogen attached to an oxygen, so also protic. What else? If I have, say, ammonia, now I have these hydrogens are attached to nitrogen, so it's also polar protic. So this is how we're going to recognize that. Now, if we can have another conditions with polar aprotic solvent. What are those? They lack of those hydrogens attached directly to an electronegative atom. So examples of that. This is acetone here. And notice that here I have three hydrogens, and here three hydrogens, but none of them, all of these hydrogens are attached to carbon, so I don't have that. So polar aprotic. And so if I had this is called dimethylformamide. And notice that here I have, that's a CH3, three hydrogens, but attached to carbon. That's also three hydrogens attached to carbon. Okay, so we don't have that. And here again, three hydrogens attached to carbon. So it is polar aprotic. So remember, this is what you're looking for when to distinguish between polar protic and polar aprotic solvent. Say that I have this. That is acetonitril. And notice the hydrogens here are attached to carbon, so it is aprotic. Lastly, another very common solvent is dimethyl sulfoxide. And here again, you have a CH3 and a CH3. All of the hydrogens are attached to carbon, so that those are polar aprotic. So recap here, then again, when predicting products, we need to be looking at what is the structure of the, say, our substrate. In many cases, we're going to be looking at alkyl halides, so we need to know where we have a primary, secondary, tertiary, and other types as well, which I'm going to be adding in another video. We also need to be looking at the leaving group, the type of nucleophile, strong, and also this reagent is. We need to remember, I have another video explaining what is in common and what is not between bases and nucleophile. Because we can have here reagents that are strong bases, strong nucleophiles, such as hydroxide, and also other reagents that may be strong nucleophile but weak bases. So depending on that type of reagent, whether we have, say, strong base, strong nucleophile. Example that I gave was hydroxide. Well, here you're likely to have both substitution and substitution or elimination products. That depends on the structure of the substrate. But if you have, say, for example, a weak base, but a strong nucleophile, such as hydrogen sulfide here, much better nucleophile than base. So here, likely you're going to have substitution and not elimination. But we're going to be doing problems to apply all of that. So again, consider the structure of the substrate, consider the leaving group, consider the reagent, what is it doing, and also you need to be looking at what is the conditions.